So hello everyone, it's Hugh here at Loxone, and I'm here with day 5 of our Foundation Series webinars. So we've already looked at who are we, who are Loxone, what we do, where we come from, what our aims and our goals are. We've had an introduction to Loxone config. We've looked at adding extensions, adding peripherals, and yesterday with Philip, you had a look at lighting control. So for today's webinar, we are going to be looking at heating control within Loxone. So this is quite an in-depth topic, but it's also one that has a lot of power and influence over how a building feels and our well-being within it. So we're going to be looking at this today for this webinar. We're going to be looking at the function blocks that make up heating control. Now, you'll notice that those 3 function blocks don't actually say heating in them. They say room controller, climate control, and temperature control. Now, the reason for this is, in this webinar, we're going to be looking at configuring heating. But these function blocks are actually capable of heating and cooling, and also bringing ventilation in as well. Because really, within a room and a room feeling comfortable or not feeling comfortable, this could be heating, cooling, and ventilation. And within Loxone, we have the ability to control all 3 of those and to bring them all in together, which is really, really important, because then we get the perfect room environment without our heating system fighting our cooling system, fighting our ventilation, all of them working in tandem to give us a comfortable living environment. So those are going to be our function blocks. We're then going to look at how we set up and configure heating, how we set temperatures in different rooms, how motion plays into heating, and then finally the parameters. So to start with, these are a few of the products that we have available for heating within Loxone. So as always, we've got the mini server on there. Mini server brains the system. It's required for everything we do. Now, functionally within the mini server, there is actually a product on the mini server that we would very, very commonly use for heating controls. That's the relays. Because just like a wiring sensor on a normal heating system, we need to be able to trigger certain products on our physical heating to turn on. We need to have triggers for the boilers, triggers for pumps, for zone valves, for hot water cylinders, for anything we may need to trigger on this system. Typically, those are going to be relays. Now, in addition to this, I've also put our Modbus extension there. So for anyone that doesn't know, Modbus is a standardization of the communication over RS485. It's very, very common within many, many different control systems. So you will see Modbus quite frequently on things like air conditioning units. You'll see them on things like heat pumps. You'll see them on MVHR units. So it's quite a common communication protocol for those kind of peripherals and those kind of devices. And we can speak Modbus through the use of our Modbus extension. So you could very, very nicely tie in something like the customer's MVHR system, their heat pump, their aircon units into the overall Loxone solution. As well as that, we have on that page valve actuators for controlling the individual flow at different points of a wet heating system. We have room comfort sensors, touch switches, touch pures, and door window contacts. So if I just stop showing my screen for a second so that you get me nice and big again, and I'll give you a quick overview of some of the different products up close and personal. So let's start with valve actuators. So with valve actuators, the idea behind these is where your TRV would go on your normal radiator, a valve actuator goes instead. Where you would normally have a digital valve actuator on a manifold, a Loxone valve actuator goes instead. So this is what the valve actuators are for. We do them as air and as tree. So this is the air version. And as you can see, that's where it would sit on the valve. That's where the batteries go. And then on the back, you do have the option to permanently power it via 24 volts as well. So you can punch down a cable onto there to power via 24 volts. So that's the air actuator. That's what you would typically put on a radiator in place of the TRV. Average battery life of 2 years, just like all of our air products. And the really, really important thing about our valve actuators is they modulate. So rather than just being open or closed, they will modulate the valve to adjust the amount of flow into that specific source. So there's the air one. Then we have the tree valve actuator. Difference here, no battery compartment. And on the back, you've now got 4 connections. This is for power and for tree comms. The tree actuator is typically what you would put on a manifold because it's going away in a cupboard somewhere. You don't want to have to worry about changing batteries. So this would typically go on a manifold. And those make up our options, our frontline products for our wet heating system. So that's controlling the flow into an area. Relays, as I just said, is controlling our main triggers. So our boiler coming on, our manifold pump coming on, etc. Valve actuators on the zones, so whether they be the manifold zones or the radiator zones. Then we need temperature readings in the room. So for temperature readings, we can take them from touch switches. So Touch Pure, and I don't actually have a standard touch on my desk, but Touch Pure or Touch has an inbuilt temperature and humidity sensor. And again, available tree or air. On the Touch Pure, you'll see that there is a nice little air gap at the side to allow nice airflow for temperature and humidity in there so it gets a quick reading. In addition to the touch switches for temperature sensing, you also have the option of a room comfort sensor. So a room comfort sensor, as you can see, physically quite similar to a touch switch, except the front of it is raised. And that's again to allow good airflow around the side. Room comfort sensor, again, tree or air. Really importantly, the air version of the room comfort sensor is temperature and humidity only. The tree version, which is this version here, is temperature, humidity, and CO2. The reason for CO2 in the tree version is for ventilation control in addition to room climate control. And then door window contact. This is air only. So the door window contact, white or anthracite, as you can see, CR2032 battery, and then you get a little metal pin which goes there to create the contact. Now, the reason for door window contacts with room climate, with heating controls, is if I have contacts on all of the windows in this room, it means that if I open a window, it can turn off the heating in that room. What's the point in spending money to heat a room up just to throw it out of a window? And so that's the functionality that these give us within a space. So again, just to recap, valve actuators for your valves, air or tree. Temperature sensor from something like a Touch or Touch Pure. Temperature, humidity, and CO2 from room comfort sensor. And door window contact so that you know whether a door or window is open so you can turn off the heating or cooling in that specific zone. Back to my screen, and as always, you will see it on all of our slides, motion sensors. Motion sensors are the magic of an automation system. They are your eyes and ears for what is happening within a room. So those are a few of the products that we can control. Then if we move on to an actual schematic of a heating layout, this is going to be the kind of thing that we're looking at configuring today. And what we have over here is we have our energy source. Now, the reason I've called it energy source and not specifically boiler is because it doesn't really matter what type of energy source it is. It could be a gas boiler. It could be an electric immersion heater within a buffer storage tank. It could be a heat pump. Air, ground, doesn't really matter. It could be an MVHR unit that can do heating and cooling. It could be oil. It could be pure electric, so electric underfloor heating or electric radiators. It really doesn't matter. We can control all of them. In our scenario today, we're going to be looking at a standard gas boiler with some underfloor heating because that's a fairly typical layout. You'd typically have gas boiler and then you'd have manifold with underfloor heating downstairs and maybe radiators upstairs. So this is our energy source. Then we have our flow and return pipes. And on our flow pipe, we have this here would be our manifold pump set. So this is where we would have our zone valve, our pump, and our blending valve or our mixing valve. Now, the reason we've drawn in the mixing valve is because we can control electronic versions of those as well. So this would be then our pump set. And then over here is our manifold. And then as you can see on each zone of the manifold is a Loxone valve actuator, which then controls the loop in each room. So we have the living room, the bedroom, the hall, and the bathroom. And these are going to be the function blocks that we're going to be looking at in this video. We're going to be looking at the intelligent room controller, the climate controller, and the intelligent temperature controller. Now, I know that that might look a lot to do heating, but there is a reason for all of them. And the reason for that is that we break down room climate control, so heating and cooling and ventilation, into a 4-stage process. Stage number 1 is the intelligent room controller. So the intelligent room controller goes in every room of the house or of the building, and this is the function block that takes the temperature reading of that room and decides what to do with the valve actuator. So in the room that I'm sitting in now, it would take the temperature reading here and it would go, you want to be 21 degrees in this room, you're currently 19 degrees, so I'm going to open the vector in this room. So that's the job of the room controller, the room by room control. In this same stage, we also have the ventilation controller. So the ventilation controller, we won't really cover on this webinar, but that would be if we were also doing MVHR control within this system as well. Once we've handled the room by room control, we move over to stage 2. Stage 2 is the climate controller. This function block looks at the demands of all of the room controllers, and if there is an appropriate level of demand, it turns on our main source of heating or cooling. So again, back to our diagram, the room controller would be every loop of our manifolds. Every room tied to that manifold would have an intelligent room controller. Our climate controller would then be over where the energy source is, the boiler. And it would look at all of the demands of all of the loops on the manifold and say, okay, there is now enough of a demand as a whole in this building to warrant me turning the boiler on. Now, the reason that it's demand-based is because if we had a house with, let's say, 15 to 20 rooms, and all of those rooms were at the right temperature and only one single room wanted heat, and it was only maybe 1.5 degrees off its desired temperature, then actually turning the boiler on could cause rapid cycling of the boiler, short cycling. It would be on and off too often, and it could degrade the lifespan of the boiler, as well as also being inefficient. So climate control is managing the overall demand. Then we move over to stage 3. Stage 3 is the intelligent temperature controller. This again looks at the demands of the room controllers and then determines flow temperature or set points for thermal stores. Now, I like to think of the intelligent temperature controller as being the function block that you use anytime you have a zone valve or pump to trigger. So for me, anytime I've got a zone valve to open with a pump tied to it, this is where the intelligent temperature controller comes in. So in our classic heating layout of a normal house with boiler, manifold downstairs, radiators upstairs, there's probably going to be 2 zone valves, so S+ wiring. So 1 zone valve for the manifold, 1 zone valve for the radiators upstairs. So in my layout, I would have 2 intelligent temperature controllers. So to me, an intelligent temperature controller is for anywhere we have zone valves. Now, the reason it says that it looks at overall demand to determine flow temperature is because we can move on to a 4th stage, which is a mixing valve controller. And this function block, again, looks at the demands of the rooms, looks at the intelligent temperature controller and actually adjusts the flow temperature out to those zones, as well as the valve actuator adjusting the flow rate into those zones. And so what we get if we do all 4 stages of this heating system is a perfectly efficient heating system, because it is incredibly efficient to manage flow temperatures, because then we're taking into account things like weather compensation. The idea being that the greater the difference between the outside temperature and the inside temperature, the greater the rate of heat loss will be. So by adjusting the flow temperature, we can mitigate that. And then by adjusting the flow rates, the amount of water into each of these zones, we then granularly adjust the temperature in these rooms, which means that we get a perfect balance between a really, really efficient heating or cooling system and also a really, really comfortable one to live in. Stage 4, you don't have to go to. You don't have to do mixing valve control, but you will, in nearly all circumstances, find yourself doing stages 1, 2, and 3. And so that then brings us back to the diagram. Now you can see with green blocks showing where our different function blocks would come into play for this heating layout. So as I said, over at the manifold, for each of these loops, we would have an intelligent room controller. So for each of these rooms, they would be an intelligent room controller. Then for our manifold pump set here would be an intelligent temperature controller and a mixing valve controller. So the temperature controller would open the zone valve and fire this pump, and then signal to the mixing valve controller at what rate to open this mixing valve, so what flow temperature was going to the manifold. Mixing valves will also commonly be called blending valves, so you might know them better as blending valves. They're typically just a twisty dial. You can leave them as that, or you could take them off and put an electronic version in its place, which we could then adjust automatically. And then finally, the climate controller is for the source. So if you're doing a multi-source system, let's say that's heating and cooling, there would be a climate controller for every source of heating and cooling. And what we then have is the ability, by having temperature sensors in each room and by having valve actuators on each loop, the ability of having really granular control. So we can set what temperature we want to be at what times in the day in each room of the property. And so our bedroom could be nice and cool so that we don't sweat and overheat when we're in bed. Our bathroom could be nice and warm so that when we get out of the bath, we're not instantly freezing cold. And our living room could be nice and warm so we can sit down, Netflix, and chill. And then I showed you the motion sensor on an earlier slide. So now we need to understand how motion comes into effect with room climate and with heating. Now, you would never use motion to bring on heating. The reason being is that it's just too much of a delay after the heating source turns on before it has any real effect in a room. Especially in something like underfloor heating, that could be 3 or 4 hours before there's actually an effect in the room of it turning on. So you never use motion to turn on heating. But what you could use motion to do is to extend your heating schedule. So as an example, if my heating schedule normally ends at 10 p.m. on a weekday in the living room, but on Friday, it's going to be Easter Friday, I'm probably going to stay in there a little bit later than normal watching a film. And so I don't want to be at 10:30, the heating having turned off, me being freezing cold, having to pull a phone out of my pocket to crank the heating up manually. What I can do is link it to motion. And so for as long as I'm in that space, it will extend the heating period for me so I don't have to worry about anything. And as per usual, everything is fully automated for us. So now that we've had a look at the slides, let's have a look at actually configuring this system live. So I'm going to move over to config. Somebody has just, oh, never mind. Somebody's just been answered their question, so I won't answer that then. So back to config. So here you have my config screen that I've been working on, and Philip has been working on throughout the last few of these webinars. Now, the first thing I'm going to start with is actually something separate to heating, but needs to be mentioned at this point. At the moment, everything we've done, we've assigned the room of kitchen. So this lighting controller in our app shows in the room kitchen and the category lighting because these are the parameters that we've set for it. And at the moment, we've just been doing all of our config on this one page here. Now, as you can probably imagine, if we get to a point where we're doing an entire building of maybe 10 or 12 rooms, each of those rooms is going to have lighting, each of those rooms is going to have heating. This page is going to get very, very busy if we put everything on one single page. And so what I'm going to do is I'm actually going to go down here at the bottom where it says page, click it, and rename this page the kitchen. And so everything I now put on this page is going to be for my kitchen. And then this little icon here allows me to create a new page. And I could call this page living room. Now, the names of these pages bear no resemblance to what shows up in the app. They're just for you to be able to make your config neater. If I wanted, I could create a page and call it rubbish. None of that naming terminology comes across in the app. Where things go in the app is all related to the room and category you give the function block. But it just allows us to neaten up our config by having things spread out across pages. And so let's get started with our heating config. Now for our heating config, I'm actually going to start at one of the end stages that I showed you earlier. I'm going to start at climate control. That is the source of heating and cooling. And the reason I'm going to start at that, I will show you as we move further down the chain. So what I'm going to do is I'm actually going to create a new page, and I'm going to call this page Whole House. The reason being is that the overall source of heating or cooling isn't related to any single room. It actually controls the house as a whole. So I should have a page here called Whole House. And again, another thing you can do with a page once you've created it is over on the parameters here, you have the option of setting a default room and a default category. So I could set a default room here of Whole House. And in that way, anything I drop onto this page will automatically get assigned to the Whole House room. And so I don't have to worry about changing the room for every single function block I drop here. Just saves me a little bit of time as we go forward. So what I'm going to start by putting a climate controller on this page. So as I said, a climate controller is for any source of heating or cooling. So this climate controller is for our boiler. So what I'm going to do is I'm going to rename it boiler, because it makes absolute sense to name things as they are so that they make more sense to us, whether it be in the app or in config for us to look over. So this is for our boiler. I'm also going to need a trigger for our boiler. So what I'm going to do is I'm going to find myself a spare digital output, and I'm going to name this digital output boiler trigger and take it onto the page. And our boiler trigger goes to the QH output. QH is the heating output. Brilliant. Also in that climate controller, over on the parameters, we have the option of changing heat type from heat pump / electric to oil / gas. This is a gas boiler, so I'm going to change it to oil / gas. The other parameters and what they do, remember, you can always click on I and it will show you a list of the parameters with a description of what they do. The only two really that are going to play into consequence for our gas boiler is the mode. So mode is 0, 1 or 2, depending on whether it automatically switches between heating and cooling. It only does heating or it only does cooling. Our gas boiler only does heating, so I'm going to change the mode to 1. And the only other parameter on the climate controller that we really need to worry about at this point in time is STR, which is start threshold. So this is the percentage of valve actuators that need to be open before there is an overall demand that warrants turning on the boiler. I'm going to leave it as 30 because 30% in an average house works out as a pretty good start threshold. So now that I have my climate controller, which is stage 2, I'm actually now going to jump over to stage 1, which is the room controllers. So what I'm going to do is head over to one of these pages that I've named as a room. I'm going to head over to the kitchen, and in the kitchen, I'm going to put an intelligent room controller. So here we have it, an intelligent room controller. Now, the reason I created the climate controller first is because, as you'll see at the bottom here, it's telling me to assign objects. I'm going to click on that grey box and it's going to open up this page here. And in this page here is where I assign my boiler climate controller. So I'm going to click add down there, which is going to add that climate controller. So you can see now I have boiler, object is a climate controller, and it's being used for heating. And that's because I said that this climate controller was heating only in the heating, in the parameter for the climate controller. So that's why I created the climate controller first. And that's also how the climate controller works out the overall demand, dependent on whether it is linked to the room controllers. So now that I've linked that climate controller to the room controller, you can see that it now says here, linked to 1 out of 1 object. So now that that's done, let's get started with putting some of our devices on this room controller. So what we need as an absolute definite is we need temperature reading and we need a valve actuator on a room controller. So let's start with temperature. We already have under our tree extension a touch tree. That is the touch that is in our demo case just here. If I expand that out, you can see that I have temperature and humidity. I only need temperature for heating. So I'm going to drag temperature out and you see a big green plus appears, oh, sorry, back onto the kitchen. I'm on the wrong page. So if I drag the temperature out onto the kitchen, you can see that a big green plus appears on the intelligent room controller. If I drop that temperature sensor onto the big green plus, it puts it onto the TI input, which is our input for temperature. So that's the correct place for it. I am then on this going to add myself a valve actuated tree. I'm going to add a tree version because, as I said, this is going to be underfloor downstairs. So I'm going to go onto my tree extension, add tree device, and then valve actuator tree. Installation place I'm going to put as manifold, room I'm going to put as kitchen. So even though the manifold won't literally be in the kitchen, this valve is to control the kitchen. So that's why I'm going to put the room as kitchen, but the installation place as manifold. Another quick point of Hugh's top tips here is valve actuated trees. You have position in cabinet row. And for anyone that remembers our extension one, that's because the valve actuated tree has a flashy light at the top of it. And when you've got them all lined up on a manifold, you can say what position on the manifold they are, and then they all blink in order. Again, just really cool, and it looks really nice. So now I've got the valve actuated tree. If I expand that, I've got the output. Drag that output again onto our kitchen page, and again onto the big green plus of the intelligent room controller, and it will put it onto an output called H1. Now, it is really, really important that it's gone to H1 because the room controller has a bunch of different outputs. Any output that has H is a heating output. Any output that has C is a cooling output, and HC is heating and cooling, because something like an aircon unit's fan speed doesn't matter whether it's heating or cooling, the fan is still blowing at a certain speed. So it obviously, as a valve actuator for heating, needs to go on an H output. But the reason why it's important it goes on H1 instead of QH is, as you can see now that I've expanded it, H1 is linked to that boiler, is linked to that climate controller. This is another reason why I added the climate controller first and added the climate controller to the room controller, because if I hadn't, I wouldn't have H1, I'd only have QH. QH is if there is no climate controller and this room controller is independent. But I do, so H1, that is important. And then finally, in the kitchen, I am going to add in one of our, in fact, I'm going to add in my door contact. So if I move over to the demo case for you, wrong webcam, let's try that again. There we go. So over to my demo case, there is a door contact in the demo case. But really importantly, this door contact is not one of our air contacts. This is just a bog standard wired door contact that actually wires into digital input 8 on the mini server. So on our mini server's digital inputs, digital input 8 is this door contact here. So I'm going to find our mini server in this list. I'm going to expand the digital inputs. Input 8, I'm going to rename as patio doors. And really importantly, I'm going to give it a category in a room. So its category is not going to be heating because I'm probably going to use it for the burglar alarm as well. So I'm going to give it a category of sensors, and it's in the kitchen. And then I'm going to drag it out, and you'll see that a big green plus does not appear this time. That's because the room controller doesn't know what to do with it because it's just a basic digital input. But it goes on IW. IW is the input for window/door contact. However, this is something really, really important to bear in mind. A door or window contact works the reverse of the normal way you would expect an input to work. A normal input is open going closed. A door and window contact is closed going open. And so what we need to do, the technical term for this, is invert it. We need to switch the way around that it works. There are two ways to do that in Loxone. The first is with a function block called not. You put not in between and that inverts whatever you put on the input to the output. So if it's open on the input, it shows that it's closed on the output. Or I can just hover over the input on the room controller until a little black dot appears on my mouse cursor, single left click, and it goes red, and that is also inversion. So you need to remember on door and window contacts to invert them. I am now going to save this in. And now that I've saved this in, I will head over to the app. However, the first thing I'll do before that, something I've missed even myself, is on the room controller, it still says it's in the room of not assigned. That's because on the parameters of this page, I didn't say that everything that I put into this page was in the kitchen. So I need to remember to do that. Everything on this page goes into the room of kitchen so that it displays in the kitchen on our web interface and on our app. So save that back in, now it's in the kitchen. Head over to our web interface. And when this mini server reboots, take a few seconds, there we go, rooms, kitchen, and here we are, new category of heating and cooling, and there is our intelligent room controller. And look at that, already we have some config in there ready to use so that it's ready and waiting for us and we can just tweak it as we need to. And what we can see here, this number here is the current room temperature. So this room is a bit toasty in here. This touch switch is currently reading 24.2. This little green temperature here is our desired room temperature. We can change these by clicking settings and then going into temperatures, and then we can change our parameters for our temperatures in this room. Now this is really important. These are exactly the same parameters that we see on the room controller itself. But I always find it much easier to edit them within the app rather than within config for our intelligent room controller. So comfort temperature, I find 22.5 a little bit warm, so I'm going to put that as 21 degrees. Tolerance is if you have both heating and cooling in a room, how far above and below comfort does it have to reach before it switches from heating to cooling mode? So tolerance doesn't really come into effect if I'm only doing heating. Not in use is our economy setback. So when we have scheduled that we're not in our comfort mode, this is the temperature range deadband in which we allow it to sit. And it's really important that the heating and cooling doesn't go off in a room. It goes back to an economy because it is always more efficient to never let a room get too cold and only have to move it up a little bit to our comfort temperature rather than to let the room get all the way down to, let's say, 11 degrees and then to crank it all the way back up to 21 degrees over a short space of time. It's much more efficient for any modulating heat source, which they pretty much all are these days. And so we would say, how far down is that room allowed to go? So maybe down to, I don't know, 17 or 16 degrees, 18 degrees, ultimately depends on the fabric of the building, and then what the upper limit is before it fires, all hell has gone loose, it's far too hot in this room. And then finally, we have off. Off is when you go away on holiday, and so you truly do want to turn your heating off. How far do you not let it go down to? So this is when I'm away for 2 weeks at a time. I don't want my pipes to freeze, so I want to make sure that the house, the rooms always stay above a certain temperature. And so those are our temperatures there. Once we've set our temperatures, we then just need to set our schedule. To do that, we just click on this green bar here, and this opens up our schedule entries. So you can see it already has a schedule for away, which goes to our frost protection. And then we have our Monday through to Sunday entries. You can see it gives us default entries of not in use in the mornings, in use throughout the day, and not in use in the evenings. We can just click on one of those, and very, very easily tweak it. So you could have it like, I would say most people that Monday to Friday, it could be maybe 6 a.m. to 9 a.m. is in use. And then from 9 a.m. through to 5 p.m. is not in use. And then from 5 p.m. through to whenever you go to bed is back in use again. But really, really, really importantly, and this is the thing that is so cool about Loxone heating and Loxone cooling, is that you don't have to schedule it to go in use before you're actually going to be using the space. But in a normal heating schedule and heating timer, you would be used to saying, okay, I'm going to come home from work at 5:30 p.m. So I better schedule the heating to come on at 4:30 so that it's at temperature by the time I get home at 5:30. Don't need to do that in Loxone. Loxone rooms will learn the heating and cooling curve in each room of the house. So you just need to set when you're going to be in that space, and it will work out what it needs to do to get you to temperature on time. So you never need to tweak these schedules day to day. It just works it out. And so that is the room controller and the settings of the room controller. Back to config, you'll see it now tells me program not identical. That's been changed some of the parameters in the app. So I'm just going to load that from the app. In addition to that room controller, nothing really else to show you on the parameters other than some that can't be edited from where we just saw in the app. So frost and overheat protection, you can't edit within the app. That's done within config. Valve standstill is really, really cool. If the valve actuator hasn't moved within the last 14 days, it does a full drive of it up and down just to make sure your valves don't seize, because of course over summer your heating's not going to be running, so it just completely runs the valves every 14 days to make sure valves don't stick. And then we have some overrun timers, and the important one here is TMV. So this is when you time motion in, how long does it extend your schedule, your comfort schedule by while you're still in the room? By default, 1800 seconds, so 30 minutes. And also delay of window contact, so how long a window has to be open for before it turns off the heating in that room. So before I forget, let's stick our motion sensor into the room controller as well. That goes into the MV input. So any room that you're going to be sat down watching TV, sat down reading a book, put the motion sensor into the room controller, it can then extend your heating period for you. So that about covers it for the room controller and for the climate controller. The other stages we've got to look at is the intelligent temperature controller and the mixing valve controller. So let's move on next to the intelligent temperature controller. So I'm going to add one of those. In fact, I'm going to add two of those into my config. So I'm going to add an intelligent temperature controller for the underfloor heating and for the radiators, because those are going to be two separate zone valves. You'll see when I dump one onto the page, a block opens up asking me what room controllers to link it to. At the moment, I only have a single room controller. I'm going to leave it unticked for a second. And I'm going to rename this intelligent temperature controller to UFH, underfloor heating, temperature controller. And then I'm going to add a second intelligent temperature controller for the radiators. So a second one. Again, I'm not going to tick anything yet. And this one is going to be radiators, or radiators temperature controller. I would then, more than likely, in a traditional heating system, have a zone valve for each, and probably a pump for the manifold, maybe a pump for the radiators. Now the pumps, I'm not going to worry about. I'm going to consider this as a physical heating system where the pumps would be wired off the zone valve. So as soon as the zone valve opens, it would trigger the pump anyway. So I'm just going to worry about turning the zone valves on or opening the zone valve. So I'm going to create two relays for my zone valves. One of them is going to be my underfloor heating zone valve. And one of them is going to be my radiators zone valve. I'm going to pull both of those onto the page. And my underfloor heating zone valve is going to go onto the output QP of this temperature controller and my radiator zone valve onto QP of this temperature controller. The next bit I'm going to do is I am going to do our mixing valve control. So as I said, you don't have to go to this stage, but if you do an electronic mixing valve, let's say on a manifold set, you can greatly increase the efficiency of your overall heating system. So as per this diagram here, you'd have a mixing valve here, which would mix in the return flow, the return water into the flow temperature to change the actual flow temperature going to these zones. So I would add myself a mixing valve controller. And really importantly for a mixing valve controller, you need two things for it to work. You need the actual temperature of that flow, and you need the desired temperature. The desired temperature comes from the intelligent temperature controller. Output AQF is desired target temperature. So you drag AQF out, and I'm going to do something called a ref. Actually drop this. So I'm going to drag out, drop to an empty part of the page, and then take my mouse to the T input, which is our target flow temperature. And as you can see, that has linked the two of them together without having an ugly line going across the page. The second thing we would need is the actual flow temperature. Now, this could be a temperature probe, one-wire temperature probe, analog temperature probe, many different types of temperature probe. I'm going to assume it's analog, so I'm just going to take an analog input from our mini server. Analog input 1 is actually also this potentiometer, so you could actually make it really simulate this. And this is going to be our flow temperature probe. And that is going to go onto AI. Then if we did have a electronic mixing valve, it would probably have two relays. One relay to open it, one relay to close it. So I'm just going to create two more relays, mixer open and mixer close. Open is going to go onto Q1 and close is going to go onto Q2. And we are one step away from having a fully working heating system. The only bit that we're missing is more room controllers for more rooms, which are then tied to these temperature controllers. So these temperature controllers first, we need to make sure that they're linked to the climate controller. To do that, select them, and in the parameters of them, they are a controller for climate control, and we link them to the boiler. Controller for climate control linked to the boiler. Now, I already have my kitchen with an intelligent room controller in, and that is an underfloor heating zone. This living room, I'm actually going to rename as bedroom, and I'm going to change the default room here to bedroom as well. The reason being is that then makes it upstairs, so we're going to show a radiator zone as well. So again, we would have a second intelligent room controller, so we'd have one in the bedroom. It's going to need a temperature sensor and a valve actuator as a minimum. So I'm going to add in just another touch switch that is going to go by the door in the bedroom, and temperature is going to go into there. And then this time I'm going to add in a valve actuator air, because this is going on a radiator. So valve actuator air on the airbase extension is installed on the radiator in the bedroom. And you'll see on an air actuator, it's actually got a built-in temperature sensor as well. Think of it like a get out of jail free card. If you needed a temperature sensor in a room with a radiator and you didn't have a touch switch for whatever reason. Now, of course, it's going to be slightly off because it's at the floor and it's next to the heating source, but sometimes it's better than nothing. I'm not going to use this one though, because I've got one in the switch, but I am going to take my valve actuator out. I'm going to link my intelligent room controller, so assign objects, link it to the climate controller, and then link my valve actuator air to that. And so now I have a room controller in the bedroom, and a room controller in the kitchen. So one underfloor, one radiators. And back over to the whole house. In the temperature controller I've called underfloor heating, I am only going to link the rooms that are on the underfloor manifold. In the temperature controller for the radiators, I'm only going to link the room controller that's on the radiators. And so this way, both of the rooms are linked to the climate controller, but only the room for the underfloor is linked to the underfloor temperature controller, and only the room for the radiators is linked to the radiator temperature controller. And so what this means is if only the kitchen is calling for heat, the boiler will turn on and the zone valve for the underfloor heating will turn on, but the zone valve for the radiator circuit won't, because it doesn't need to. And that then is a completed heating system. Stages 1 through to 4. Room controller for each room of the house. Climate controller for the source. Temperature controllers for zone valves and pumps. And then mixing valve controller for the blending valve, the mixing valve on our underfloor heating manifold. And if I go back to live view, you'll be able to see that in the bedroom, I've currently got a reading of 0 degrees. That's because that temperature sensor doesn't physically exist yet. So that means that this room will be calling for heat. And you'll see that there's about a minute poll time before this valve actuator opens. In the kitchen, however, there is no call for heat because we're already above our desired temperature. And so what will happen is when this bedroom reaches a point where it needs heat, the valve actuator will open. And then once the valve actuator opens, the boiler and the zone valve for the radiators will also open, but only providing we have a suitable enough demand. So we can already see, there we go, boiler is turned on, radiator zone valve has opened, but the underfloor zone valve hasn't. We can also see that the mixing valve controller is already working and it is already adjusting the flow temperature based on what it's reading and what the target is. And back over to the bedroom, again, there is that slight delay, but you will see as well in a second that the actuator will open in the bedroom as well. And then my final point, rooms. Again, critically important that you input room sizes in square meters into each of your rooms because it's used in the internal heating and cooling logic. And once you've configured your system, the next really important thing, leave it running. Give it a week just to bed itself in, to learn the heating and cooling curves of the rooms and adjust as necessary. And what you will see after a few days is it will be nigh on perfect. The only things that could throw it out would be things that Loxone can't control, such as blinds being open in a room and we're not controlling the shading and lots of sunlight streaming in and overheating a room. But again, if we had cooling, we could manage that as well. And here we go. Mixer is now back opening again. Boiler's still on. Zone valve for the radiator still on. And I think it's because I don't really have a valve actuator there that one isn't opening. But you can see everything working exactly as it should. Back over to the web interface, into each of the rooms. We can see that the bedroom is heating up. So even though we aren't in our comfort schedule for the bedroom, it's currently heating up already because it has learned that we need to get there. We need to start heating up now to get to our desired temperature on time. If I head over to the category of heating and cooling, you can see that I can also see our climate controller in there, which is telling us what the demand is in each room. So we can see that the kitchen is overheated, so it actually needs to cool down, and the bedroom needs to heat up. Wonderful. Don't forget as well that you can also simulate these things. So we could go into the evening through simulation, and we could also then manually adjust these temperatures in simulation as well. so that we are therefore simulating these things happening and then seeing the real result of them. Brilliant. So there we have it. So we have the stages, so room controller, climate controller, temperature controller, adding temperature sensors, adding motion sensors, adding door window contacts. Oh, something really cool to show you about the door window contact. I'm not going to make you wait 5 minutes. So if I just change that to 5 seconds of a door or window being opened, let's see what happens in the app. So that's now a 5-second delay of a door or window being open before it has an effect on the room climate. So kitchen, here we go, kitchen, open the door contact, 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5 Mississippi. There we go. Patio doors are open, scheduled entries are ignored. So now that this door is opened, you can see that once we've hit that timeout, it's ignoring our schedule and it's gone back to the frost protection and overheat protection mode. Close the door again, and we're back to our normal schedule. Wonderful. I'm going to change that back to 300 because we should only do things like that to test rather than to keep. I'm going to stick the camera back on me. And that about covers it for our heating and our cooling logic. Thank you very much for joining. Please join me again next time. Hope you've enjoyed. And as always, the videos for this series, as well as the config files and the slides that I've shown you today, will be available on our website. And if I just head back to our slideshow, just to show you the final couple of slides that we had on the parameters. So temperatures in each room, effective motion, parameters. And as always, on the function block, you can click I to show you the parameters for what that function block does. But for the intelligent room controller, these are a few of the really, really important parameters. Most of them I find easier to set within the app or the web interface. For the climate controller, these are some of the more important ones. Mode and start threshold, I think, are the critical ones, as well as heating type. So a heating type of electric/heat pump or oil/gas. And for the intelligent temperature controller, you will see in that one that you can set a minimum and a maximum flow temperature. So if you are controlling a mixing valve, you can set what you want your minimum and maximum flow temperatures to be. Finally, just as we always do, all of this backed up by powerful software. Hopefully you're starting to see the power of config and what it can do. And then as a final point, as always, if you would like to get your hands on a demo case to try these things out for yourself, there is the person you need to contact. Please get in touch with Megan, give her a call, send her an email. Thank you very much, everyone, for joining. See you next time, and goodbye.